Hello, can you all hear me? Hello, hello, who are present, can they hear me? Hello, can anyone unmute and tell me whether I am audible or not?
Yes, sir, you're audible, sir.
Okay, thank you, thank you. So we will wait for a few more minutes, let others join, and then we will start at 7:10. And my slides are visible. Like here, you can now you see in title slide. It's written NPTEL, then Experimental Physics 1. All are visible.
Yes, sir, visible.
Okay, thank you for confirming. So we will start after 5 minutes. So, hello everyone. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So, I welcome you all to this course Experimental Physics 1, which is being flowed by NPTEL this semester for July 2025 session, and the course code is NOC 25 PH51. So I will be so this is a I will be taking a number of interaction sessions. So this is our first interaction session. So I'll be taking interaction session weekly on Friday at the same time from 7 p.m. to 9 p.m. My voice is clear to everyone? Okay, so these are the details of the live interaction session. So as we all know, the course code is NOC 25 PH51 and the name of the course is Experimental Physics 1 and the course coordinator is Professor Amal Kumar Das from IIT Kharagpur. So this is the meeting link, and for those who have not the who have not accessed the meeting link, then for them they can join through this meeting ID and password, and the live session timings will be every Friday from 7 p.m. to 9 p.m. starting from today, that is 1st August 2025. Also, after this interaction session is completed, the interaction session is being recorded and the recordings will be uploaded to my YouTube channel, where you can access the videos, as well as I will be I'll be uploading the presentation files, which I will be discussing the problems and their solutions. That will be again uploaded to the Google Drive, and the link to the Google Drive you will be getting from NPTEL side through email. Or if you have any doubts regarding the um, course content and all, you can ask me. I will be very happy to discuss with you. So now, if you talk about the course contents of this week one. So today we will be solving a few problems that will be based on again the lecture contents of week one for this course. So in first week, the So in past week, mainly lectures was based on mechanical tools that covered the nuts, bolts, washers, screws, nails, then wrenches and screwdrivers, and solder irons, how you do soldering and all the components like iron, solder, flux, and weight sponge. And regarding the measurement tools, meter scale, slide calipers, screw gauge, and galvanometer were discussed in the week's lecture. So now we will be solving a few problems that will be based on the measuring tools and all. So talking about the meter scale, so this is a sample meter scale. So the maximum length of this scale is 15 centimeter, and the minimum reading that we can get is 0.1 centimeter. So this 0.1 centimeter, which is the minimum reading we can measure through accurately with this scale or measuring device, it is called as also the least count of the measuring device. Now, if you see, this is another scale, but here, as you can see, in between 2 millimeter lines, there is another line. So here it is 0.05 centimeter. So the least count is 0.5 millimeter or 0.05 centimeter. But here the least count is 0.1 centimeter or 1 millimeter. So depending upon the accuracy, depending upon the least count, whether our measurements are accurate or not, that we can get an idea about it. Now talking about the significant digit and output digit, here you see the least count. Can anyone tell me? Suppose this is A and this is B. There are two scales. So can anyone tell me what is the least count of scale A? Yes, anyone?
Sir, it is 1 centimeter.
Exactly. So here, as you can see, in between 0 to 1, there are no divisions. So we can't say what is the value in between. So here the accurate reading that the minimum accurate value that we can get is 1 centimeter, because there are no other divisions in between 1 and 2 or 0 1 or is digits. So here the least count is 1 centimeter. So suppose I will say for this scale I measured some, suppose this is a block, I am measuring with this scale, and I said the length of this block is 2.5 centimeter. Can I say this? Yes. So if I am measuring with this scale A, and I measured and I told you the value is 2.5 centimeter, is it correct or not?
That's doubtful, sir.
Exactly. So the significant digit here will be 2, but this 5 is doubtful because we don't know whether it is 5 or 6 or 3, because the least count is only 1 centimeter. But for scale 2 or scale B, if you see, I suppose this is the pin so this is a pin whose length we are measuring. Now, as you can see, it lies between, it lies at 3. So 2.3 we can say, so 2.3 is significant. But if I say 2.34 or 2.35, then this 4 or 5, they are doubtful because the least count of this scale is 0.1 centimeter or 1 millimeter. I hope this is clear to everyone. Then now let's talk about a few rules that governs the significant digit and doubtful digits. So, as you can see, rule 1 says all non-zero digits 1 to 9 in a measurement are significant. So, for example, if 237, so 237 here all are non-zero digits 1 to 9. So, here it has 3 significant figures, and here 1.894 it has 4 significant figures. Now the second rule says all digits from 0 to 9 in the coefficient of scientific notations are significant, but those digits in the base, that is into 10 and the power, are not. For example, here if you see 1.40 and 10 to the power 3, it has 3 significant figures, but here 3.008900 into 10 to the minus 12, it has 8 significant figures. So here it's written, but those digits in the base and the power are not significant. So that's why here it has 3 significant figures, and here it has 8 significant. These are not being considered. So these are a few rules that you already have come across in the lectures also. So for a few examples are here. For example, 1, 2, 3, it has 3 significant figures. The leading zeros are not significant. So this 0.0045, which are leading zeros before the non-zero values or non-zero digits, they are not significant. So 0.0045, it has 2 significant figures. And talking about captive zeros like 101, since it is in between two non-zero values, so it is significant. So here 101, it has 3 significant figures. Now the trailing zeros in decimal number are significant. So when decimal is present, that all the trailing zeros has value. So here 1.200, it has 4 significant figures. Suppose 1.4500 560. So it has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 significant figures. Similarly, trailing zeros in a whole number without a decimal point may or may not be significant, and that depends upon the context. So scientific notation should be used to clarify it. And then let's solve our first question of the day. So the question says the mass and volume of a body are 5.325 gram and 2.5 centimeter cube respectively. The density of the material of the body in appropriate significant figures is, options are option A 2 gram per centimeter cube, option B 2.13 gram per centimeter cube, option C 2.1 gram per centimeter cube, or option D 2.2 gram per centimeter cube. So here the question says the mass and volume of a body are given. So mass is given is given 5.325 gram, and the volume of the body is given. So volume is also given. So V is 2.5 centimeter cube. So now we need to find out the density. We know density is mass by volume. So what will be the value of the density, and also it is mentioned in appropriate significant figure. So what will be the appropriate significant figure? We have to decide or determine. So I will give a few minutes to solve this question and tell me the answer, and then we will discuss. So can anyone tell me what will be the correct option?
सर आंसर बी होगा.
So you are saying 2.13 gram per centimeter cube.
Yes sir.
Okay, so any other answers?
Option C.
So one is saying 2.13 gram per centimeter cube. So then we have another answer which says option C will be correct, 2.1 gram per centimeter cube. Any other answers that you are thinking which is correct? So uh, so you are from which course, like which background? Are you in BSc or MSc? So can one by one you tell me? Let's start with Krishna. Can you tell me about yourself, like your name and the course you are in?
Yes sir. सर मेरा नाम कृष्णा देव यादव है सर. और मैं
So
बीच में ड्रॉप आउट ले लिया था सर. जो मैं ओपन यूनिवर्सिटी से मतलब बीएससी का कोर्स कर रहा हूँ, सेकेंड ईयर में हूँ सर.
Abhi, okay. So you are from BSc. So next, Pratham Bhatt. Can you hear me, Pratham? Okay. So if you are leaving, so now Saswat.
A BTech Instrumentation and Control Engineering.
Okay. So because I need to know your course so that when I am explaining something, so I will explain accordingly. Like whether you are the background in physics, like from plus two basics or plus three, like that. That's why I am asking you about your courses that you are in. Then Sanghamitra A.
I'm from physics, BSc physics.
Okay. So you are from either BTech or BSc. So okay. So let's discuss this current problem. So it says the density of the material of the body in appropriate significant figure. So if you divide, we know it's very simple. 5.325 divided by 2.5. So 5.325 divided by 2.5. So it will come around 2.13 gram per centimeter cube. But here the question says the density of the material in appropriate significant figure. So what is the appropriate significant figures? So here see, in question there are two values. So in mass it is 5.325. So in 5.325, what is the number of significant figures? Yes. Anyone? So in
Sir,
5
four
point,
significant digit है.
yes. So in mass it has four significant figures, and in volume it is 2.5. So in 2.5, what is the significant figure? Or what is the number of significant figures?
Sir, two.
2. So here it has two significant figures. So the rule says if we are in a problem, we have been given some values, the result should have the same number of significant figures as the values with the fewest significant figure. So the result will be having the number of significant figure which is the least number of significant figures out of the given values. So here it has four significant figures, it has two significant figures. So the least number of significant figures is 2, this one. So our answer should be of two significant figures. So if you reduce this answer to two significant figures, it will be 2.1 gram per centimeter cube. So the correct option will be option C, 2.1 gram per centimeter cube. Is this clear to everyone? So if there are some values provided in the question and we need to calculate a solution, so the result will be having the number of significant figure which is the least number of significant figures for a given value. So in the question it has two given values, one is mass and another is volume. For mass it has four significant figures, for volume it has two significant figures. So our result should have the least significant figures out of the given values. So the least significant figure out of the given value is 2, which is 2.5. So our result will be having two significant values, so two significant figures. So if you calculate the result, then it will be 2.1 for two significant figures. Is this clear to everyone? Yes.
Yes, sir.
Okay. So you know the name of the session is what? Interaction session only. So it will be good if you interact with me. So it will be better for you also, for me also, because I can know you better. I can discuss with you many other things also. So let's go to question number 2. So question number 2 says the number 8.255 on rounding up to three significant figures will give, options are option A 8.26, option B 8.25, option C 8.30, or option D 8.20.
Sir, option A.
Okay, so anyone, any other answers?
Answer B, sir.
Okay, so one is saying
Sir, answer A.
2.6. Okay, so So you see, when like in the previous question, we reduced this to 2.1 because here see the 2.13, this 3 is less than 5. So if the answer was to be calculated or was to be given in 3 number of significant digits, then we can either write to 0.21 sorry 2.10 because 3 is less than 5, so we can write it 2.10. Similarly here if you see the value is 8.255, so it has 4 significant figures. So if you want to reduce it to 3 significant figures, then we have to eliminate this 5 because otherwise there are 4 significant figures. So now here it is 5. So we know when it is the at the last figure it is 5 or more than 5, then it is when you are reducing the number of significant figures, then it will be the higher value for the adjacent value. So when we reduce this to 3 significant figure, then it will be 8.26 because 5 when it is present at the last position, then it will be added, so 1 will be added to the preceding value. So this is 255, then it will be 260. So since 8.255 is given 8.255, so it is 8.260, and since the answer should be given in 3 significant figures but 8.260 has 4 significant figures, so the correct answer will be 8.26. So here the correct answer will be 8.26, that is option A. Is this clear? If it would have been, suppose the it was 1.254, then what will be the value in 3 significant figure?
8.250.
No, in 3 significant figure. If you are adding 0, then it has significance. Now when the zeros are added in after the
Trailing
decimal
zeros.
point, okay, so it will be 8.25. So since here it is 4 is less than 5, so we are reducing it to 8.25. But since here 5 is present, so we will add another value to the preceding value, like 5 will be replaced by 6. So it will be 8.26. Is this clear to everyone? Yes, is this clear?
Yes, sir.
Yes, sir.
Okay. Okay,
Yes,
so
sir.
now we'll move to question number 3. So question number 3 says diameter of a steel ball is measured using a vernier caliper which has divisions of 0.1 centimeters on its main scale and 10 divisions of its vernier scale, which matches with 9 divisions on the main scale. 3 such measurements for the ball are given below, and the zero error is minus 0.04 centimeter. So here it is minus, so it is not hyphen, so it is minus 0.04 centimeter. Then the reading will be, options are option A 1.56 centimeter, option B 1.52 centimeter, option C 1.60 centimeter, or option D 1.54 centimeter. So the measurements are given in the table. So serial number 1, the first measurement, the main scale reading was 1.6 centimeter and the vernier divisions were 6. In the second reading, 1.5 was main scale and vernier division was 8. And in the third reading, 1.5 centimeter was the main scale reading and the vernier divisions were, the vernier division was 4. So these are the 3 measurements. So 1, 2, 3. So these are the 3 measurements, and we need to find out the reading of the actual value, or that is the diameter of the steel ball. And we are measuring the ball with the help of a slide calipers, and the slide calipers, the main scale has 0.1 centimeter division and the 10 divisions of vernier scale, that coincides with 9 divisions of main scale. So with this information, we will solve this problem to get the value of the measurement, that is the diameter of the steel ball. So I'll give you a few minutes to try this question and solve it to get the correct answer, and then we will discuss. So before solving this question, so is there anybody who has seen the slide calipers in real life? Have you used it? Any one of you?
Yes, sir.
Okay, so you
Yes,
have
sir.
used slide calipers.
Yes.
Okay, so good. So now let's discuss a few things about slide calipers, and then we will start or we will continue solving the question. So here in this slide you can see a picture of the slide calipers. So these are the external jaws that are used to measure the, like, in certain cases the external jaws are used, and in certain cases the internal jaws are used. For example, suppose there is a solid cylinder and we want to measure the diameter of the cylinder. So we will place that cylinder here and we will measure the diameter. But suppose there is a cylinder which is hollow and we want to measure the inner diameter of that cylinder. Then we will place the cylinder here. Like suppose this is a cylinder. So in order to measure this internal diameter, so these internal jaws are used. So external jaws means it we will be placing it at the external of a measuring device, or internal jaws are used for measuring the internal diameters and all. And there is a locking screw because this scale, so this is the normal, so this is metric scale, this is imperial scale. So imperial scale means it is in centimeter. Sorry, imperial scale is in inch, feet, they are called imperial scale. Then metric scale is millimeter, centimeter, like that. So these are two scales present here. So here there are, so this is the main scale. So this is the main scale and this is vernier scale. So here you can see there are number of digits that are corresponding to the metric scale, and the upper number of digits that are corresponding to the imperial scale. So here also you can see here it is written the least count is 0.02 mm, and here the least count is 0.001 inch. So we will discuss how we will be calculating the least count for a given measuring device or slide calipers. And if you talk about another part, this is a depth measuring blade. So if you want to, so there is a group. Suppose there is a group and we want to measure the height of this group. So we will place, suppose this is a group, suppose the group is present like this, and we want to measure the height of the group. So we will place the slide calipers here, and we will suppose this point, it will be like this. So we will be measuring what is the depth by placing the slide calipers on the top of this group by using this depth measuring blade. And if you talk about the zero error, because in our question also it is mentioned that the zero error of the slide caliper is minus 0.04 centimeter. So what is zero error? So basically zero error comes when the now here in the scale we here there is gap between the external jaws and internal jaws. Now I will close this slide caliper, that is there will be no gap, and this will coincide with this line. Then if the in that case, if so this is main scale and this is vernier scale. So when the main scale zero reading coincides with the vernier scale zero reading, it is called as no zero. The zero error is called as zero. But when they doesn't coincide, then we will be calling that the system or the slide caliper or the measuring device has zero error. So when it is positive zero error, when it is negative zero error. So when the zero of vernier is to the right of the main zero, then it is positive reading, and the when the zero of vernier scale is to the left of the zero of main scale, then it is called as negative zero. For example, suppose actually this value should be zero, but we are showing 0.02. So then it will be positive zero error, and suppose the value is zero and we are measuring minus 0.02, then it will be negative zero error. So can anyone tell me this B case whether it is positive zero error or negative zero error?
That is positive error.
Yes, so it is positive because as you can see here, the main scale 0 is to the left of the vernier scale 0, or the vernier scale 0 is to the right of main scale 0. So when main scale is 0, vernier has positive non-zero values. So here this is positive 0 error. Similarly, this case is different. Here the 0 of main scale is to the right of the 0 of vernier scale. So it is negative 0 error. Is this clear to everyone?
Yes, sir.
Okay, so in short, if you want to remember, when the zero vernier scale measures positive value in main scale, then it is positive zero error. When the zero vernier scale measures negative value in main scale, it is called as negative zero error. And when both the zeros of main scale and vernier scale coincide, then the system, then the measuring device will be having no zero error, or that is the zero error is zero. So there are no errors in measurement, and we don't need to introduce any correction after measuring the uh, so now let's come to our question. So the question says, so the diameter of a steel ball we are measuring, and here the vernier caliper has 0.1 centimeter in its main scale. So the least count of the main scale is 0.1 centimeter, and the 10 divisions of vernier scale matches with 9 divisions of main scale. So let's first calculate the least count of the vernier caliper. So the least count of the vernier caliper So for main scale, it is 0.1 centimeter or 1 millimeter, and 10 divisions of vernier scale equals to 9 divisions of main scale. So what will be the least count? So the least count will be 1, that is 1 mm minus 9 by 10. So this 9 by 10 means 9 division of main scale coincides with 10 division or equal to 10 divisions of vernier scale. So or will be in mm, it will be 1 minus 0.9 mm, which is 0.1 mm. Or alternatively, how we can calculate? We can calculate the least count is smallest division in main scale divided by number of divisions in vernier scale. Number of divisions in vernier scale. So smallest division in main scale was how much? It was 0.1 centimeter, then divided by 10 divisions. So it was 0.01 centimeter, or we can write 0.1 millimeter. So the least count of the given slide caliper is 0.1 millimeter. Is this clear to everyone? So now here you can
Yes,
see.
sir.
So can you see this vernier scale? So how many divisions are here in this vernier scale? Can anyone tell me in the vernier scale for this metric scale, the bottom one? So how many divisions are present in this vernier scales?
Sir, 50 divisions.
50 divisions. So and also this main scale, the minimum value is 0.1 always. So for main scale it is 0.1, and for vernier scale the divisions are, so the main scale one division is 0.1 centimeter, and vernier scale has 50 divisions. Then what will be the least count? Yes. It will be,
Sir, 0.002, sir.
yes. So it will be 0.1 divided by 50, that is 0.002 centimeter or 0.02 millimeter. So the least count is different. Also you can see here it is written 0.02 millimeter. So here it is written 0.02 millimeter. So depending upon the number of divisions in the vernier scale, you can determine the least count, and smaller is the least count, more accurate is your measuring result. So now let's come to our question. So so in the question it was 1.5 and the vernier divisions was 6. So what will be in first case, what will be the measuring value? Let me add another slide, then it will be better to. So the actual measurement value, how we determine the measurement value? The measurement value is main scale reading plus least count into Vernier coincidence. Vernier coincidence. That is least count into the uh, uh, digit or the number of line that coincides with the main scale. So here it is given in the question. It is given Vernier division is 6, Vernier division is 8, and Vernier division is 4. So what will be the measurement value in first case? Serial number 1. It will be 1.5 plus 0.1 into 6. Sorry, 0.01 in centimeter. Everything is given in centimeter. So see here, see this is in centimeter. So this part will also be in centimeter. So if you convert it to centimeter, it will be 0.01 centimeter. It will be 0.01 into 6. So it will be how much? 1.56 centimeter. Is this clear? So first reading 1.5 and 6, it will be 1.56 centimeter. In second case, it is 1.5 and 8, so it will be 1.58 centimeter. And in third case, 1.5 and 4, it is 1.54 centimeter. So now we, since we have three measurements, then we need to calculate the mean of the measurement. So what will be the mean value? It will be 1.54 plus 1.56 plus 1.58 divided by 3, is not it? Then what will be the mean value? Anyone?
So 1.56 centimeters.
Yes. So 1.56 is the mean value from the measurement. So this 1.56 centimeter would have been the correct answer if there was no zero error. But in the question it is mentioned, if you see the question correctly, the zero error is minus 0.04. So when the error is present, we need to subtract that error. So the actual measurement value will be, the actual value will be measured value minus zero error. So measured value is 1.56 centimeter minus zero error is minus 0.04 centimeter. So it is 1.56 plus 0.04, which is 1.60 centimeter. So the correct answer will be 1.60 centimeter. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So now we will move to the next one. I hope this was uh, uh, okay. So let's discuss the next one. The question was the basic use of a moving coil galvanometer is, options are option A, measurement of potential difference, option B, measurement of resistance, option C, measurement of small currents, or option D, measurement of electric field. So what is the basic use of a moving coil galvanometer?
Measurement of small currents.
Yes, so moving coil galvanometer is used mainly for measuring small currents. So the
Small.
correct answer will be option C. Now if we discuss more about a moving coil galvanometer, so in this slide you can see a schematic diagram of a moving coil galvanometer. So there is a upper suspension through which a mirror is connected, and then there are coils that are rolled over an iron core which is stationary, and then there is a spring support that is present, so which is also called as lower suspension. Now this coil is again present in a magnetic field. So this is the front view, but if you see the top view, so this is the top view. So from top, the magnets are curved like this because only then the magnetic lines of force will be perpendicular. So when this happens, then this coil, when current flows through a coil, then due to electromagnetic induction, it will experience some force, and due to that force, so here you see, suppose this is north and this is south. So what is the direction of magnetic lines of force? Can anyone tell me?
Sir, from north to south, left to
So
right.
it will be like this: north to south, north to south. So here, since this surface is curved, then the magnetic lines of force will be perpendicular. So then, so now here you see, suppose the current direction is like this. So for this part, current is flowing in upward direction, but for this part, current is flowing in downward direction. So due to two different direction of current, they will experience equal and opposite force, but along the same line of action. For example, this is the coil. So one will, sorry, 1 minute. Let me. Hello, am I audible? Sorry, there was some notification. So let's discuss. So when current are in opposite direction, so in it will, so for one end it will be, the force will be in this direction. For another end it will be force in this direction. So when the two forces are equal and opposite, and they don't share a common line of action, then they result in a torque. So it will experience a torque, and this coil it will rotate. So this so it will rotate. So accordingly, so why this mirror is placed? So when this mirror is placed, so some light is focused into the mirror, and that reflects the light to a scale. So when this coil is twist, so the light will move in that scale, and in order to come back to its original position, this spring is present. So if we calculate the torque will be So if we calculate the torque due to the magnetic field, it will be N A B I, where I is the current, N is the number of turns, A is the area of cross section, and B is the magnetic field. So this is the torque experienced. And if you talk about the restoring torque, so the restoring torque will be K into theta, where K is constant and theta is the twist in that spring. So these two are equal. So N A B I is equals to K theta, or I will be K divided by NBA into theta. So I is direct proportional to theta. So um, more is the current, more twist or more torque it will experience, and there will be more twisting in the spring. So like corresponding to the twisting, there will be movement in the mirror. Like suppose there is a scale, so initial light was here. So when there is twist, the light will be shifted to here only. So from this distance, we can calculate the value of theta. If we know, suppose this is the scale is placed here and the mirror is placed here. So this is the distance d, and this is, suppose this is the distance that the light moved. This is L. So we know theta is equals to R by L, isn't it? So theta is equal to, sorry, L by R. L by R. So here it will be L by D. L by D. So accordingly, we can calculate the value of the theta, or the value of current we can also measure from this reflection. So here the correct answer will be measurement of small currents. So now let's move to question number 5. So question number 5 says, when a current of when a current of 0.001 ampere flows through a moving coil galvanometer, it gives full deflection. It is converted into a voltmeter to read voltage up to 10 volt using an external resistance of 9950 ohm. What is the resistance of the galvanometer? The options are option A 150 ohm, options B 50 ohm, option C 80 ohm, and option D 100 ohm. So this question is quite interesting. So basically this question is based on the concept how we convert one galvanometer into voltmeter or galvanometer into ammeter, depending upon the connections we are changing, or depending upon the modifications we are doing in a circuit. So the galvanometer, which is generally used for measuring small current, that can again be used for measuring voltages as well as currents. So when we are measuring voltage, then it is called as voltmeter, and when we measure current, it is called as ammeter. So these are the four options, and I will give you a few minutes to think about this question and try this and solve it to get the answer, and then we will discuss what will be the correct answer. Yes, so can anyone tell me what will be the resistance of the galvanometer?
Sir,
Anyone?
option B.
We were saying option B, that is 50 ohm. So how did you calculate that?
So by using V is equal to IR and
So can you tell me if you want to convert one uh, galvanometer to voltmeter? Basically here we need to convert it to a voltmeter which can read up to 10 volt. So what we need to do to convert an galvanometer to a voltmeter?
connect high resistance to it in series, sir.
Okay, so when we are connecting a high resistance to in series to a galvanometer, then it will be converted to a voltmeter. Absolutely correct. So if we are connecting, if you uh, draw the circuit, suppose this is the galvanometer, and we connected a high resistance to it, and total we want, and we want to check the to convert it into a voltmeter required up to 10 volt. So this total will be 10 volt. So so you know Kirchhoff. So all of you you know Kirchhoff's law.
Yes, sir.
So anyone other who doesn't know, so that I can explain it a bit more.
यस सर
Anybody know
बताइए
Kirchhoff's
भूल
law?
गया सर आता नहीं है.
So basically Kirchhoff's law is related to the current and voltage values corresponding to a electrical circuit. So it says when suppose in a electrical circuit there are multiple branches, so the total current coming to a point is equal to the total current going out of that current. For example, suppose this is a circuit, so current I1 is coming, I2, I3, I4, I5 they are going. So I1 will be equals to I2 plus I3 plus I4 plus I5. And for this is called as current rule. Then for voltage rule, so when you are applying some voltage across across an electrical circuit, then the applied voltage will be equal to the voltage drop across individual elements. For example, this 10 volt we are applying, so the voltage drop across this galvanometer, that is Vg, and voltage drop across this resistor, that is Vr. So 10 volt will be equal to Vg plus Vr. And also there are two other things that we should keep in mind when we are talking about a series circuit. Then in series circuit the current remains same, and in parallel branches the voltage remains same. For example, suppose this is a circuit where there are resistance, suppose there are three resistance. So if current I is flowing in this branch, so at each point current I will flow. But if the branch gets separated into two branches, so here current I is going, then it's splitted into I1 and I2, then this I1, I2 then again come and then they give Y. So here I will be I1 plus I2. So here this I is constant, but the voltage drops across the resistance, they are different. Like this will be V1, this will be V2, this will be V3. So voltage will be different and current will be constant. But for parallel circuits like here, this voltage will remain same. So the voltage drop across this resistor will be equal to the voltage drop across this resistor. But the current in two branches, that will be different. So here current is not constant, but the voltage is constant. So this thing we will use here in the question. So here the question says we have a galvanometer here and we have connected it to a high resistance, and we need to measure the voltage, and the maximum voltage is 10 volt. So if the maximum voltage is 10 volt and the question says the current flows, the current current of 0.001 ampere flows through a moving coil galvanometer. So since this galvanometer and this resistance both are in series, this is 9950 ohms, and this current I is flowing. So see this current Ig, what is the value of this current Ig? It is given, it is 0.001 ampere. Is this clear to you? So
Yes,
can you
sir.
get that circuit? So this is the circuit. So now the question says it gives full deflection. It is converted into a voltmeter to read up to 10 volts. So the total voltage drop, suppose the voltage drop across this galvanometer is Vg and the voltage drop across this resistor is Vr, and the suppose the resistance of the galvanometer is Rg. So we want to find out the value of Rg, and this R we know it is 9950 ohm. So the total voltage 10 volt, it will drop across galvanometer and it will drop across the resistor. So what is the voltage drop across the galvanometer? So what is the formula for voltage? It is current into resistance, is not it? Ohm's law, V is equals to IR. Everybody know Ohm's law?
Sir.
So you sorry, what did you say? Yes or no?
Yes, sir.
Okay. So Ohm's law says V is direct proportional to I, or V is equals to IR. So the voltage drop across this galvanometer will be current flowing through the galvanometer and resistance of the galvanometer, and the voltage drop across this resistance, it will be current flowing through resistance and resistance of the resistor. So can anyone tell me uh, uh, whether Ig and IR they will be different or they will be same? Ig and IR. So Ig flows through galvanometer and IR flows through resistor. Whether these are same, whether these two are same or different.
Same रहेगा, sir.
Exactly, because here the
Same,
circuit
sir.
is in series. So here since it is in series, so same current will flow across each component in a series connection. So here, so again, if you apply the Kirchhoff's law, this 10 volt, it will drop across this galvanometer Vg and this resistance Vr. So let me add another slide, B2. So this total 10 volt, it will be equals to Vg, voltage drop across galvanometer, and voltage drop across resistor. So what is the voltage drop across galvanometer? It is Ig into resistance of the galvanometer plus what is the voltage drop across the resistor? It is again Ig into R. So we know the value of Ig because it is given in the question. Ig is 0.001 ampere, 0.001 into Rg plus again Ig is 0.001 into R. R is how much? R is 9950. 9950. So if you take 0.001 common, it will be Rg plus 9950. So Rg plus 9950 it is equal to 10 into 10 to the power 3, because here it is 10 to the power minus 3. So it will be 10 to the power 4. Is this clear up to this point?
Yes, sir.
Everyone is clear? Any other response? All are clear? Okay, I hope since you are not.
Yes, sir.
Okay, so I need to change the slide position. So Rg plus 9950 is equal to 10 to the power 4. So Rg will be 10 to the power 4 minus 9950. So it is 10,000 minus 9950. So it is 50 ohm. So the resistance of galvanometer is 50 ohm. So the correct answer will be option B. Is this clear to everyone? Yes. So in order to convert a galvanometer into voltmeter, we need to connect a high resistance in series, so that since the current remains same in a series line, so majority of the voltage will be dropping across the resistance, because V is equals to IR, and the small amount of voltage it will drop across the galvanometer. So since galvanometer has full scale reading of the full scale reading of 0.001 ampere, so depending upon the series resistance, the range of the voltage it can measure, that can be changed. For example, here it was 10 volt, so we connected 9950 ohm of resistance. So suppose we want to measure 100 volt, then we need to connect higher resistance in series, then only it will be able to measure that voltage. Is it clear? I am audible, na? You are not responding. Hello.
Yes, sir.
हाँ sir, audible.
So when you are when you are stopping to respond, then I might be not audible, I thought. So let's. So I hope the previous question was clear to everyone, because these questions are quite important from the point of view of your exams, also from point of view of your class exam, as well as from the point of view of this NPTEL exam, because these questions are quite interesting. How you are converting galvanometer to voltmeter, galvanometer to ammeter. These are quite interesting. Also, uh, have you ever used multimeters? Anyone? Anyone of you have used multimeters to measure voltage, current, resistance, and all? Basically, multimeter is a device
Yes, sir.
that can measure
Yes, sir.
multiple parameters. So while you are measuring in the multimeter, when you are measuring voltage and current, there is an option to change the range of the voltage and current. That is the maximum voltage you can measure. Have you ever tried that by changing the range?
Mhm.
Have you ever thought of the mechanism that is being employed here to change the voltage range? This is this mechanism only. So when we connect different resistances, the range also improves. So when you change the range of that multimeter, then what it does, it just changes the position of the resistance, like it changes the value of the resistance that is connected in series. So when the resistance value increases, the voltage also increases, because the voltage drop will increase depending upon the resistance. That is the principle of changing the range of voltage as well as current. Okay, so now question number 6. Question number 6 says the given image is of a table galvanometer in which A and B are two magnetic poles. Now the option says what is the correct option? Options are option A is North Pole and B is South Pole. Option B is North Pole and A is South Pole. Option C, both A and B are North Pole. Or option D, both A and B are South Poles. So can anyone tell what will be the correct answer? Yes. This image you can see clearly. Yes. Anyone?
Sir,
What will be the correct answer?
sir, A is North Pole and B is South Pole.
Yes, exactly. So how you are saying A is North Pole, B is South Pole?
Sir, based on the direction of magnetic field lines.
Exactly. So here the magnetic field lines, if you see, the arrows are like this. So this is the direction, and for A, this is the direction. So the magnetic lines are coming from A and they are going towards B. So magnetic lines of force, they move from north to south pole. So A is north and B is south. So the correct option is A is north pole and B is south pole. That is option A. Is this clear to everyone? Okay, so let's move towards the next one. The question says a student used vernier calipers to measure the diameter of a wooden cylinder. The diagram shows the positions of the main scale and the vernier when the measurement was taken. What reading was recorded? The vernier constant of the scale is 0.1 mm. So can anyone tell me, the scale is given here? This is the main scale and this is the vernier scale. The vernier constant is given 0.1. Vernier constant is nothing but the least count of the scale. Then what will be the reading value taken for this particular position of the scale? Yes, anyone? So why you stopped responding? ये बात क्यों नहीं कर रहा? Hello? Everybody
हाँ
can
सर.
see the slides?
Yes
Everybody
sir.
can see the slides. Okay, so what is the main scale reading? Because here we need two things. Since we know the least count, that is 0.1 mm, so we need the value of main scale and the value of vernier scale. So what is the main scale reading here?
2.65.
No, what is the main scale
Sir,
reading?
sir 2.6.
Exactly.
Centimeters.
So here 2, this is 1, this is 2, this is 3, 4, 5, this is 6. So 2 points. So main scale reading is 2 point. So main scale reading is 2.6 centimeter. Now here, what is the vernier scale division that coincides with the main scale? 1, 2, sorry. This is 1, 2, 3, 4, 5, 6,
4.
7, 8, 9. So this 4, it coincides with the main scale value. So here vernier value is 4. So what is vernier scale reading? Vernier scale reading 4 into 0.1 millimeter. So it will be 0.4 millimeter. Is not it? So if you convert it, since main scale reading is in centimeter, so main scale reading is in centimeter, that is 2.6 centimeter. Vernier scale reading is 0.4 millimeter. So when you convert it to centimeter, what will be the value of vernier scale reading?
0.04 centimeter.
0.4 into
0.04 centimeter, because 1 centimeter equal to 10 millimeter. So 1 millimeter is equal to 10 to the power minus 1 centimeter, or 0.1 centimeter. So 0.4 millimeter is 0.04 centimeter. So total reading will be main scale reading plus vernier scale reading 2.6 plus 0.04 centimeter, which is 2.64 centimeter. So the correct answer will be option A, 2.64 centimeter. Is this clear to everyone? Let's try another case. Suppose this is the case. So this is 1, 1, 2, 3, 4. Suppose this is main scale. So here it is 5, 5. So 1, 2, 3, 4, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Now I will be drawing the vernier scale. Suppose this is the vernier scale. So it has 20 divisions. So can anyone tell me what will be the value in this case? Suppose this is 20 division, means it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. 19 and 20. So here you see this 11 coincides with the main scale reading. So what is the main scale reading here?
So 2.1 centimeter.
2.1. So 2.1 is main scale, 2.1 centimeter is main scale reading. So vernier coincidence is 11. What is the least count of this vernier scale? If the vernier scale has 20 divisions, what is the least count of vernier scale?
So 0.05 centimeter.
Sorry, not centimeter, millimeter. It's 0.05 millimeter or centimeter. Anyone? Least count will be 0.05 millimeter or something else. So how to calculate least count? So it is smallest division in main scale, that is 0.1 centimeter, then divided by, sorry, it is 0.1 centimeter, then the number of division is 20, is not it? So what will be the value? 0.1 by 20. Anyone? 0.1 centimeter divided by 20 will be
0.005 centimeter.
yes, 0.005 centimeter, that means 0.05 millimeter. So it is 0.005 centimeter or 0.05 millimeter. So main scale reading is 2.1. So vernier incidence is 11. So vernier scale reading will be 11 into 0.055. Sorry, 0.05. So it will be 0.55. Sorry, centimeter if you convert it. Let me add another slide. So main scale reading was 2.1 centimeter. Vernier scale reading is 0.05 mm into 11, that is 0.55 millimeter, which is 0.055 centimeter. So total it will be 2.100 plus 0.055 centimeter. It will be 2.155 centimeter. Is this clear to everyone?
Yes, sir.
So depending upon the slide caliper, the least count of the slide caliper, you can have different values. So I hope this is clear to everyone. Now we will move to the next one. The question says, what should be the value of the shunt resistance to be connected in parallel of the ammeter coil in order to increase the range of the ammeter to n times, where n is any real positive number and Rg is the resistance of the ammeter. The options are option A, S equals to n minus 1 into Rg, option B, n minus 1 divided by Rg, S equals to Rg divided by n plus 1 or Rg divided by n minus 1. So this is again another important question which is based on the concept of converting a galvanometer into an ammeter. So we need to find out what will be the value of the shunt resistance. So I'll give you a few minutes to solve this question and then we will discuss what will be the correct answer. Yes, anyone?
Sir, option D.
Option D.
Yes,
Okay.
sir. S is equal to Rg by n minus 1.
Okay, so any other answers from the students? So this question is based on converting a galvanometer into an ammeter. So we know in order to convert a galvanometer into an ammeter, we connect a low resistance in parallel, which is called as shunt resistance. So this is the circuit. So this is the galvanometer, and we have connected another resistance in parallel. So this is the current that flows to the galvanometer, which is called as Ig, and Rg is the resistance of the ammeter. So this is Rg, this is the resistance of the shunt S. So now the question says, what should be the value of the shunt resistance to be connected in parallel of the ammeter coil in order to increase the range of the ammeter to n times. So now this is Ig, we need to increase the range to n times. So what will be the value of total current? So this will be Nig. So this Nig, Ig will flow through this ammeter or the resistance Rg, and then the remaining will flow through this S. So if Nig is the total current, what will be the value of current that is flowing through this shunt branch, that is S? Again, this is also Nig. What will be the value of current that is flowing across this branch? Anyone?
Sir, Nij minus Ig.
Yes. So it will be Nig minus Ig or N minus 1 Ig. So as we have already discussed, we know the voltage across, suppose, so these are two branches and they are parallel to each other, and we know the voltage across the parallel branches remains same. So what is the voltage drop across this upper branch? So this will be Ig into Rg. Similarly, the voltage drop across this lower branch, it will be N minus 1 Ig into S. So since both these voltage are same, so Ig into Rg will be N minus 1 Ig into S. So S will be Ig into Rg divided by N minus 1 into Ig. So Ig gets cancelled out. It will be Rg divided by N minus 1. So S is Rg divided by N minus 1. So Rg divided by N minus 1, and the option is Rg divided by N minus 1, option D. Is this clear to everyone? Anyone? Is this clear to everyone, or anyone has any doubts? Okay, so here the question was, what should be the value of the shunt resistance that should be used to increase the range of the ammeter to n times. So initially it was Ig, so the range we need to increase n times, means the total current will be Nig. So if Ig is flowing through the ammeter, because for ammeter the same current will be flowing, so if before and after the range, same current will be flow through this ammeter, and the remaining current will flow through this shunt. So the shunt resistance, depending upon the value of shunt resistance, the remaining current will flow. So Rg into Ig will be equal to N minus 1 into Ig into S. So if you solve this, we will get S equals to Rg divided by N minus 1. So depending upon the value of N, we can get the value of shunt resistance. Suppose N is 1, so shunt resistance will be infinite. Suppose N is 2, then shunt resistance will be Rg. Suppose N is 3, then shunt resistance will be Rg by 2, like that. So depending upon the range of the current we want to measure, the resistance will be different and different. Suppose we want to measure more current, the shunt resistance will be smaller and smaller. Is this clear to everyone? Okay, so let's move towards the next one. So question number 9. Question number 9 says a galvanometer has resistance of 10 ohms and a full scale deflection is produced by 5 milliamperes. What is the value of the resistance that should be connected in series with it in order to enable it to measure to read 5 volt? So the options are option A 220 ohm, option B 510 ohm, option C 30 ohm, or option D 990 ohm. So this question was pretty much similar to the previous question. That one question we solved regarding the voltmeter one, that was 10 volt, but here it is 5 volt. So it will be solved accordingly the same way. So can anyone tell me by solving what will be the value of the resistance that we need to connect in series so that we can change the range to 5 volt? Yes, anyone? So we all know we need to connect the resistance in series. So this was the resistance, that is the galvanometer, and this is the main resistance. So this is Rg and this is R. So we need to find out the value of R, and Rg is given to us 10 ohm, and the current that is flowing Ig, this is given as 5 milliampere, and we need to find out the value of the resistance that should be connected in series in order to enable it to read 5 volt. So total voltage is 5 volt. So 5 volt is equal to Ig into Rg plus Ig into R. So 5 volt equal to Ig into Rg plus Ig into R, which is Ig into R plus Rg. So 5 equals to, it is 0, sorry, it is 5 milliampere. So it is 0.005. R is not known to us. We have 10 ohms. So R plus 10. This is 5 into 1000 by 5 equals to R plus 10. So R will be 1000 minus 10, which is 990 ohm. So the correct answer is 990 ohm. Is this clear to you?
Yes, sir.
So the correct answer will be 990 ohm. So the correct option is option D. So if you change the value of the series resistance, you can change the range of the voltage. I hope this is clear to everyone. Now we will move to question number 10. So question number 10 says a galvanometer having a coil resistance 50 ohm gives full scale deflection for a current of 0.05 amperes. To convert it into an ammeter to measure up to 5 amperes, what is the shunt required? The shunt required is a options are option A 0.5 ohm, option B 0.2 ohm, option C 0.1 ohm, and option D 0.01 ohm. So I'll give you a few minutes to think about this question and calculate the answer, and then we will discuss. Yes, anyone? What will be the correct option?
Sir, option A.
Option A 0.5 ohm. Yes, option A is correct. So if we solve it, then we know in order to convert the galvanometer into an ammeter, we need to connect a small resistance in parallel. So this is uh, galvanometer Rg, then small resistance R. So uh, uh, 50 ohm is the resistance. This is 50 ohm, and the current is this current Ig. It is 0.05 ampere. So the total current is 5 ampere. So since 0.05 ampere is flowing here, it will be 5 minus 0.05 ampere, which is 4.95 ampere. So we know the voltage across both the branches will be same. So Ig into Rg will be equals to I into R. So this is I. So I is 4.95 ampere. So Ig is 0.05 into R. So R is 50 equals to 4.95 into R we need to calculate. So R will be 0.05 into 50 divided by 4.95. So calculate and tell me what will be the answer. So it is coming out 0.505 ohm, or if you see the options, 0.5 ohm we have. So it is 0.5 ohm. So the correct option is 0.5 ohm. Is this clear to everyone? So this was another example of how we can convert a galvanometer into ammeter by connecting a smaller resistance in parallel, so that most of the current flows through this smaller resistance path and minimum current flows to the galvanometer. So with this we come to the end of the today's session. I hope this was useful for everyone. Then in the next interaction session we will be solving a few problems that will be again covering the week 2 lectures of the course. So with this, so is there any doubt in the today's problems? If anyone has any doubt, they can ask me. Okay, if this is the case, then I think we should stop it here. That's it from my side. Thank you. Good night.
Thank you, sir.
Okay, welcome. So as I had told you, I will be uploading the slides as well as the recordings of this session, and you will be getting the Google Drive link from NPTEL.